All right, welcome to question, I believe this is 9. We are tackling a new type of question of pumping liquids from a container. We just want to take note that the weight density water we're going to be given it if it's ever on an exam at 62.4. We have a diameter of 29 and the sides of the pool we'll get back to later. But for part 1, we suppose that a slab has been created at an arbitrary value y with a thickness del y. Find the approximate volume of such a slab in terms of y. So for part 1, we need to find the area of this slab. So the area of a circle is pi r squared, and we need a thickness del y right here. Now we actually already know our diameter, it's 29, so our radius is just going to be 14.5 squared pi delta y, which is evaluated 210.25 pi del y, and that is our answer to part 1. Part 2, assuming the forces required to lift the slab equal to its weight, and since the pool contains fresh water having a weight density of 62.4, the force required to lift this slab is F of y. So we're given volume times weight per unit volume. So just exactly what we have times our weight density. 62.4 times 210.25 pi delta y. That's equal to F of y. And that is our answer. Or we can simplify that a little bit more. So we're going to move down here to part 2. 62.4 times 210.25 is 13,119.6 pi del y. That's our answer to part 2. And now we just have to plug this into our integral. The limits of integration portion where the liquid resides in the pool, and the force when you act through a distance of 4 minus y, which is our del y. So first we're going to write it, and just as it is. And we need our del y, but we have it right here, our distance 4 minus y dy. And we want to find our limits of integration. So that is just going to be the sides of the pool 4 feet tall, and the pool is filled to a depth of 2.5. In terms of y, it's going to be that 2.5 since we're mentioning depth. So 0 to 2.5. Now that's the answer to part 3. Lastly, we just have to evaluate the integral of part 4. So pull the constant outside. 0.25 4 minus y dy. Using power rule, we have 4y minus y squared over 2. Bounds of integration. Plug that in. The zeros are just going to cancel everything out. So 4 times 2.5 should be 10. But we want to combine these like terms. So 2 over 2. 10 times 2 over 2 is 20 over 2. Minus 2.5 squared is 6.25 over 2 is equal to 13.75 over 2. And then that is just equal to 6.875 times our constant outside, which is just 1319.6 pi. And that is our answer for part 4 and then question 9.